In this video we will focus on Minkowski inequality in L2 for complex valued functions. We have two functions uw which are complex valued. So the mapping is from domain omega to the complex set, and same for w. So we're going to prove this inequality. We take the norm of u plus w in L2 squared. That's going to be the integral over omega of u plus w modulus squared d omega. Now the integrand, we're going to write this as u plus w times u plus w conjugate d omega. And that's going to be the integral over omega u plus w times u bar u conjugate plus w conjugate d omega. That's going to be u times u bar plus u times w bar plus w times u bar plus w bar d omega. I split the integral and I have u times u conjugate d omega plus the integral over omega u times w conjugate plus w times u conjugate d omega plus the integral over omega w times w conjugate d omega. So u times u conjugate is going to be the modulus of u squared, is a complex valued function, plus the integral over omega, that's going to be 2 times the real part of u times w bar d omega plus the integral over omega modulus w squared d omega. Okay, so that integral, the first integral is the norm of u in L2 squared plus 2 times the integral over omega real of u times w bar d omega plus the norm of w in L2 squared. We can bound that by modulus the norm of u in L2 squared plus 2 times the integral over omega modulus of u times modulus of w d omega plus the norm of w in L2 squared, and that's going to be norm of u in L2 squared plus 2 times the integral over omega modulus of u. The modulus of the conjugate is going to be equal to the modulus of the complex valued function w d omega plus norm of w in L2 squared. Then I can use the Schwarz inequality to bound the second integral, and I will have norm of u L2 squared plus 2 times so it's going to be the norm of u in L2 times norm of w in L2 plus norm of w in L2 squared, and that's going to be norm of u in L2 plus norm of w in L2 squared. So already I have that the norm of u plus w L2 squared is less than or equal to the norm of u in L2 plus the norm of w in L2 squared. I take the square root on both sides of the inequality, and I have that the norm of u plus w in L2 is less than or equal to the norm of u in L2 plus the norm of w in L2, and the proof is completed, and that is the Minkowski inequality. In L2 for complex valued functions.